Okay, thank you, Azra. Everyone, please. Okay, Aurel, Ahdan, Evan, Yasmin, Kanzu, Ahmad Alfar, dan Geraldi. Dimas. Halo Pak Dendi.
Pagi, morning semuanya.
Everyone, Arvin, Igustinora Lydia, thank you. Hasya, okay. Alika, Arvin, Muiz, Ulaya, Bintang, Sherry. Okay, yeah. So we're gonna open the camera every lecture, yeah, just the beginning, just few minutes. So at least you're ready, I'm ready, yeah, Pak Dendi's ready, okay? All right, let me Sherry and Muiz, please. Okay, sometimes when, for example, yesterday there are few students also, they are still like traveling, using the phone, so we know how you actually listen to us, yeah? Okay, let me, okay, so I'm gonna take a picture so you can smile. Thank you, okay. Okay, thank you. Okay, so looks like you are already in Bandung and then maybe in your kosan, yeah. We will also check the time as well. If it is okay, then maybe some weeks later we can also arrange time for real lecture in the campus, yeah, during. Okay, thank you very much. You can close your camera if you want. Right. Okay. The next steps is you have to check your presence at CX. So I'm gonna just check a little bit. There should be 25 people here. Okay. So Jilan, Gifari, Emeralda. So please click on your presence, and then okay. So before we start, and also I'm gonna also explain to you about the EduNext. I was with you as well with the statistic last semester. So for this case, okay, let me open that one. Which one? So you can find the EduNext, yeah, for engineering materials 03. Have you enrolled to the class or not yet? You can open your microphone.
For me, yes, ma'am, already.
Okay, so you should be able to. Yeah. Okay. So everyone should be able to enroll. Yeah. Okay. So similar to the statistic, what I'm gonna do every week, before the class, I will put the module here before the class, so you can either download it or either take a note, take a picture for this one here. And also I will also add in the sub module there's some additional videos. I took it from Coursera. So if we look at here, there are a few videos that sometimes we will replay it again. This is from Coursera, from University of California, yeah, UCL. Just to enhance your learning activities, okay. And then after the class, the recorded videos also will be put into this EduNext link, so you can, if you think you don't understand during the class, you can replay the videos and then try to find which one the part that you need to study more. Okay, so remember 3 credits, 3 SKS, yeah, that means you have to spend around 3 multiplied with 3, so around 9 hours per week for these engineering materials. Okay. Let me start the screen for today. Okay. So everyone, welcome to TK2206 Engineering Materials. So these are the team teaching for the engineering materials. In class 01 is Pak Ahmad Zainal Abidin and also me in the regular classes. The second class, the second class K02 is Pak Pramujo, Pak Dr. Pramujo, and also Pak Hafiz. And for international class, we have the lecturer me, Bu Winny, and also Pak Dendi, and also Pak Hafiz. Okay, so we're the team teaching, so that ensure that we deliver the similar materials every week, and we will also have similar exams, similar all the rules, yeah, for everybody. Right. So the for the course rule, the assignment. Okay, so the 1 hour lecture is 50 minutes, around 50 minutes, and during the real lecture in the class, usually we tolerate up to 10 minutes for a 1 hour lecture or 20 minutes for 2 hour lecture. Okay, but I really want you to emphasize that for the this online class, it's really good just if you can do it on time, so we can move on very quickly. Okay, so and then there's a present requirement about 75% and during the class, if we arrange the real class, yeah, luring, you should be appropriately dressed, so you have to appreciate yourself, appreciate your appreciate your friends, and also appreciate the lecturer as well. So you need to of course appropriately dress. Wait, need to. Okay, so the next one is so in the class also you have to wear shoes, don't wear sandals, and no food and drink during the course, and no phone during the course, except we need to open the online EduNext, for example, or online videos by lectures. Okay, this is very important, so you can write down or you can have a look this one here. So we have quite a lot of assignments. The assignment is designed for you to help you, yeah, to help you for the exam, yeah. So we have exam module 1 UTS 1 and also exam module 2. Okay, and both actually have a percentage of 40%, and the assignments, the total assignment is 20%. Okay, so the you will I will explain it in a minute, but basically the engineering materials will contain a lot of knowledge, yeah, knowledge and skills, and then not much calculation. It's not very difficult like math, yeah, or analytical mathematical things. It's not, there's no differential or something. It's just all about the formulas, but it's quite but so many formulas and so many knowledge that you're gonna learn. So the only way to prepare the exam 1 and exam 2, as you have to do a lot of assignments. You have few assignments that's designed to help you to be able to get used to the exam. Okay, if you think you failed on exam module 1 and module 2, there would be a final exam, and the final exam is treated as remedial test, whereas the final exam UAS is actually would comprise of 50% mark, and the other 50% mark is assignments, exam module 1 and exam module 2. Okay, but again, I don't recommend you to do UAS, yeah, why you have to do the remedial test if you can do good in the UTS1 and UTS2, right? And then there is no a follow-up test if you can't uh, come to UTS1, then yeah, you just don't do the test. And of course there is no yeah, dispensation on plagiarism. So if we found that you do plagiarism is E, yeah. But actually, because it is would yeah, we actually the exam is always open book, yeah. But open book sometimes means a bit scarier. But the exam would be always open book and open notes. So but not open internet, of course. So you don't need to. So you have to again build your integrity to do your work properly. Okay, up to here, any questions, everyone? Is it clear enough?
Excuse me, Miss Winnie, can I ask a question?
Yes.
Actually, I am not registered yet in this course, but I choose this course because there are other courses that has a clashing schedule. So can you please invite me manually to the EduNext, because I will add this course formally on February 8th next month.
Oh, okay. Yeah, yeah. Who is the class coordinators for this class? Okay, so please arrange who's the class coordinators, and I will give you the token, yeah, the token for the EduNext. Okay. Okay, thank you, Evan.
Thank you very much, Miss.
Okay, now what we gonna learn this semester? I think it would be good if we can do it offline, yeah. So because engineering materials is all about things, yeah, about the materials. It's about this glass bottle. It's about this plastic or the PE bottle. It's about, for example, the punch made of metal, or about the material of your pipelines, or how to design the material for the tank. Yeah, it's all about things, and then which you can feel, you can hear it, and then you can feel it. Okay, so what I'm gonna do, what we're gonna learn in this week is or in this semester is actually, first we're gonna so this week, which is now and tomorrow, we will talk about the introduction, of course, with this one, and then the core syllabi, and the introduction to engineering materials. Yeah, so what is engineering materials? Bahan konstruksi, if we translate it into English, is called engineering materials, not construction materials. Why? And then we're gonna see it in a few seconds. And we're gonna start from the structure, yeah, the crystal structure of solids. Okay, and next week we're gonna learn about defect or imperfection. If we think that defect is not good, yeah, but in solids you will learn that a defect is actually advantageous. Once you have a defect, if the solid has a defect, has a dislocation, the properties will improve. Yeah, so that is the interesting about solids. And then once we know the structure and also the defect on the solids, and then we're gonna move on to the impact of the structure, which is the mechanical properties of the metals. Okay, so actually for exam module 1, from week 1 to week 7 or week 8, we're gonna learn a lot about metals. Yeah, logam. So we're gonna start with metals or logam. Okay, and then we gonna learn in the second week about mechanical properties. How is the strength of this bottle? How, for example, how about the ductility? Later on, we're gonna learn that one. How about the hardness, kekerasan, and so on. So many mechanical properties, which is the impact of the structure. And then we're gonna learn about dislocation or slip. And this dislocation, it actually will impact on the strengthening mechanism of metals. So the good thing about metals, we actually can engineer the metal. We can make the metal or the steel, for example, ya baja, ya in English called steel. We can make steel like that is very strong, so we can put it into the building, ya sebagai baja tulangan, ya as the reinforced concrete for building maybe 7 or 10-story building. Or we can make the steel that can be used for the equipment or for the scissor or the knife for the operating, for the medical purposes. Okay, or we can make steel for biomedical purposes. Okay, so even me, I had a bone cancer a few years ago, and my left hand now is no, sorry, the bones now is changing with metal. So I have a stainless steel inside my this one, the left arm, yeah. And then so the strengthening of mechanism of metal, we can engineer, we can customize the properties of metals to vary application, and because this is the good thing about metal. Okay, so once we know how to strengthening mechanism of metal, the next step is about failure, kegagalan. Okay, of course, if we want to design a metal or design a tank or a reactor, of course we don't want them to failure, yeah, to have a failure, kegagalan. It can be fracture, patah, it can be fatigue or lelah, yeah, or others type of failure. Okay, and then in week 5 because we want to know the processing of metals, we're gonna learn phase diagram of the metals and the oxides, and based on those phase diagram, the next steps is we're gonna learn about the microstructure changes, the microstructure changes, and how that impact to the properties of the iron and carbon, which is the iron and steel system. Okay, because the thing is, if you have a different composition or you have a different microstructure, your properties will change. So how to understand that one? So it would be in the week 6. Okay, and then it's gonna be concluded with the applications of those metals. Sorry, it should be the metals there, and also the processing of metals, and then there should be tutorials as well. But before that, in here there should be around 3 to 4 assignments. Yeah, this maybe every 2 weeks, to make sure that you can evaluate your understanding in incrementally. It's not so it is actually quite a large topics, yeah. It's almost half the book, and then it will be concluded with the exam number 1. Okay, and then the next steps is Pak Dendi will also explaining to you about the ceramic. So this is about keramik, yeah, or ceramic, based from the structure and the characteristic and the application and also the processing. Okay, and then the next one is Pak Hafiz will explain about a polymer, from the structure, characteristic, application, processing, and also the composite. Maybe you want to ask why this only 2 weeks, yeah, for ceramics and polymer, because once you understand the structure to learn the material from metal, you know the basics, yeah. So then you can learn anything, yeah. So then this would be the ceramics and the polymers. And then it will be concluded with composite, and again with Pak Dendi with new materials, and then with tutorials, and also with the exam module 2. Right? Okay. So I like to study or learn from the book. So this is the books, the William Callister Rhetoric, Material Science and Engineering, and 9th edition. The cover of the book, I put it into the profile picture of our Edonex. Yeah, so if you want to see, so find the book. The book is also similar with the one that is taken by your kakak tingkat. Yeah, so please feel free to ask them how to get the book. Okay, so now about the course syllabi, please, if you have any questions. Any question, everyone? Is it quite clear? Okay, right, looks like it's clear, so let's move on. Okay, so wait. Okay, so what are engineering materials? Okay, so engineering materials is actually used for so raw material for any construction or manufacturing and in an organized way, and with the application known as engineering material. So it can be classified as metal or polymer or ceramic or hybrid or composite. Okay, the materials engineering or for example, our friends at the materials engineering, the technique material. So that it actually refers to selecting the correct material for the application in which the engineered part is being used. Okay, so the selection process includes choosing the material, paying attention to its specific type or grade by the required properties. Okay, so the material selection is a very, very important topics and important projects. For example, in lab KPEE with Pak Hardev or Pak Pramujo, Bu Isdi, they have a lot of I think they have a lot of projects regarding from the industry which is required material selection. So they're asking which material which is very suitable for their application industry. For example, what is the suitable material for reactor, for pipeline, for valve, for storage, and then when during the operation and during the day-to-day operation up to few years, if there's something wrong with the material, for example corrosion or the maybe defect or something, and then they evaluate it again. Okay. Okay, and then so the engineer, we as an engineer, usually the material engineers will select a particular grade of materials based on its properties such as malleability, tensile strength, kuat tarik tensile strength, hardness, kekerasan, chemical inertness, and so on. Okay, so design of the process equipment including piping will require the material selection, so it can be clearly defined to ensure safety as well as the cost effectiveness of the equipment. In a more restricted sense, material engineering will also be referred to as a material of construction. Okay, right. Now let's see the material timeline. I hope it is quite large enough in your screen. So so if you think about it, the ability of the humanity to be able to process materials, it defines the age, peradaban. Okay, so many years ago, before century, we actually it's called Stone Age, zaman batu, so see, so from the stone, from flint, the prehistoric, or using the wood. So because at that time they use a lot of equipment using the stone, and it is called Stone Age, zaman batu. Okay, and then it's move on to thousands before century, the Copper Age, which means that they have been utilized copper, tembaga, yeah, copper, the smelted copper, and also for the other one there is a pottery, and then cement, and also the glass, and as well the paper, the papyrus, yeah, for the papers, that one there. Okay, and then we also understand that 1000 AD, yeah, the Iron Age, yeah, we saw a lot of I think if you like watching movies, Game of Thrones, something, a lot of this is it's called Iron Age because they have been able to process iron. Okay, so using the iron. So this is rhyme was quite long, and then from the other non-metals there is paper, and then also using tortoise shell and gutta percha. Okay, and then they also invented rubber, and around 1800 AD, which is about with the industrial revolution industry, yeah. So there would be a lot of invention, yeah, regarding the magnesium, the tungsten, all about the system periodics. Okay, again, I like to read books about so my supervisor from Australia gave a book to me called about Uncle Tungsten. So the book tells you about around 1900 and about how there's a family who can invented they love chemistry, and they invented many the chemicals, yeah. So this one, so there is cobalt, zinc, nickel, steels, and so on. Okay, and then around 1900, then it also again increasing with we call it age of steel, because the humanity can make steel, stainless steel. Yeah, the difference with steel from iron besi, yeah, well, the stainless steel is baja tahan karat. Okay, and then in the polymer side, there is invention which is called bakelite around 1909, and the bakelite is actually become the first type of polymer, and then from that one the polymer is just increasing. Okay, and then around 1940 is around a lot of super alloys, and then also increasing types of polymer, PET, Teflon, yeah, Teflon for frying, for the pan, Lycra, and so on, and HDPE, and so on, and up to now is called the molecular age, or the nanomaterials. Okay, so this is the evolution of engineering materials, which is related with the importance. So, for example, this area here around 1960s, the age of polymers and the age of these metals really have a very high importance related to the development, pembangunan. Yeah, the evolution of age, peradaban, of course, is really supported by these engineering materials. And now we are in the around 2020, we're in the development becoming slow again for the metals, and usually we mostly control about the quality control and also the processing. Okay, here and also if you look at here, this composite is actually a combination between polymer or ceramic or metal with composite and so on. So combination of 2 or 3 types of materials. Okay, the natural composite is straw and brick. For example, to make a house, and they build the brick, and after that they put a dried straw, pakai jerami kering, and they put it into the wall, and then top it with tanah liat, yeah, or a clay, so it ensures a stronger house. And then there is a paper as well around year 0, and then here around 1960s to now, there is a lot of development in composite, from graphite fiber reinforced polymer, fiberglass, the one that is your house, the atap, or maybe your tennis racket using carbon fiber, your bike, sepeda, the sepeda, and so on. Okay, and the last one is ceramic. Ceramic is not only the pottery, it's not only the pottery that you want, but the ceramic is actually comprised of glass. So this glass is actually a type of ceramic. The difference of glass and the ceramic is actually, glass is non-crystalline while the ceramic is crystalline, but the ceramic is oxide. And then it expand into cement, refractory. Refractory means bata tahan api, the one that used to make a furnace. And then Portland cement, silica cement, and then pyroceramic, and then tough engineering ceramic. Okay, so that is the evolution of engineering materials. So, and then we as a chemical engineers also need to know these types of material. Right, so this is a very important slide. So this is the key aspects and components in materials engineering. Okay, so I'm gonna make sure, for example, this one. So this is called alumina. Alumina is A2O3. Wait, where is the? Oh, this one is pen color. Yeah. So this is A2. So I didn't bring my Wacom. Just wait. Okay. This is Al2O3. All the specimens are alumina, but we have a different properties. The properties that's different that we're looking at is actually the optical transparency. Yeah, so this is opaque. This is opaque. This is transparent. This is translucent, and this is opaque. Okay. Why? It is a similar chemical compound, but it has a different properties. Why? Because it has a different structure. Okay, because maybe in high school or in the first year you learn about chemistry. Okay, so the chemistry is the same, but in reality, especially solids, if you have a different microstructure, then you will have a different properties. Okay, so this is the 4 components of the discipline of material science and engineering, and also their interrelationship. Okay, the first one is called structure. The structure is the arrangement of the internal components of material, and the structure is defined at several levels. It can be from subatomic, atomic, microscopic, and also the macroscopic. The subatomic is from the proton and neuron and the electron, something like that. And the atomic level is in each atom level. Okay, so for example, there are some arrangement of those metals. For example, body-centered cubic (BCC) or face-centered cubic (FCC) or hexagonal closed package (HCP). We're gonna learn this tomorrow. Yeah. So if the compound has different atomic arrangement, later on it will impact on different properties. Okay, the microscopic level. Why is called microscopic level? Because we actually look at it at the microscopic using a microscope, or now we call it using scanning electron microscope. So there is a equipment in ITB as well, in Center of Advanced Science. This SEM or scanning electron microscope is able to magnify the for example, any materials that you want, powder or something, up to maybe 1 micron, 1 or half micron, or maybe few micron. Or if you want, you can check again with, we call it TEM, or transmission electron microscope. It can be also 10 to the minus 9, yeah, 2 nanometers. Okay, so this is microscopic. If we can understand the microscopic scale of the material, then it will have the impact to the application, to the properties and the performance. Okay, and the macroscopic level is the naked eye, when we see the material in a naked eye. Okay, now so the structure, so different structure will result in different properties. Okay, for example, I want to make steel, carbon steel for a reactor. Okay, so this is the carbon steel for reactor. Okay, so this is the structure we look at with the microscope. We have the good one, and then okay, so it can withstand for the reactor. Okay, and the next one, I want to make steel, but should be but the steel is actually for railway, untuk rel kereta api. Okay, so that means for railway, you have to have properties that should be wear resistant, harus tahan aus, yeah, or should be strong, because it can hold the load of the trains, harus bisa menahan beban kereta api. Okay, so then in the structure, of course, that would be different with the microstructure between that one, the stronger one for the railway, and with maybe only withstand with the atmospheric pressure for the reactor. Of course, that would have a different properties. Okay, and these properties will result into the performance, the application. Do you want to make steel for railway? Do you want to make steel for the maybe for the reactor, or maybe for the piping, okay, or maybe only for the bridge something, okay? So, and now how to get the structure is how to do it, the processing. So different processing will result in different structure, okay? Different processing will result in different function. Okay, so the properties again here, the trace of materials in terms of the kind and magnitude to respond to specific imposed stimuli, and the match between properties and requirements imposed on the practical use of materials will determine the performance. And how to get that structure? Using the processing. Okay, so in this class, from week 1 to week 7 or 8, we're gonna start first with the structure first. Okay, in the first 2 weeks, we're gonna learn about the structure, so we understand the structure of metals. And then the next one, we're gonna learn the properties, the mechanical properties, and then after that, we're gonna check the performance, and then the end is the performance, application, and also the processing, how to get that one. Right, okay, so the material is actually based on the, there are properties of material, mechanical, electrical. Okay, let me start screen again. Okay. Okay, can you see my screen now? Yeah, okay. Okay, so the properties of materials, so I'm going to continue again. The properties of materials, it can be mechanical, electrical, thermal, magnetic, optical, or destructive, which is mean corrosive. And again, as an engineer, we also need to consider the cost, the cost of material. If you build something with the very good properties, So in the third year, I also teach separation process, and we have to design a distillation column. To in the third year, and then you will also see me as well. And then the students need to design with type of material. One group, they choose stainless steel, all of them stainless steel, for example. But in a sense, we actually don't need that stainless steel, because the fluids or the gas, the vapor inside inside the distillation column is actually doesn't have a corrosion properties. It's not corrosive. So if you insist to build the distillation column using stainless steel, it is good, but it is fancy, terlalu mewah. Why? Because the cost of stainless steel is 6 times the cost of carbon steel. So it's like if you want to buy maybe phone or I don't know, any equipment. So we also need to consider the cost as well. So I know there's a trade-off between the properties and the cost, but this is the we have to consider the cost as well. And then also we also need to select the availability of material, the desired shape and quality, and also the reliability of the supply. And then how is the surface life? If we want to design a reactor, is it withstand for 10 years or 20 years or 15 years? It's gonna be a hassle if we build the tank, for example, or reactor, and after just 5 years it start to broke. So then we have to have the downtime, and then we have to reorder the tank again or the reactor again. So it's gonna costly. And then the appearance materials is also like if it would be one preference as well. Okay, so need to check the next one. Okay, right. So the classification of engineering materials. This is the metals. There is a polymers. The polymers is this is, for example, the metal. I have a punch, so it is from the metal, so from maybe iron or steel. And then also alloys or non-ferrous alloys, for example, based on aluminum, copper, zinc, or titanium alloys. Okay, and this is an example of polymer, for example, polyethylene or PET or polycarbonate, PC, polycarbonate, polystyrene, and it's your styrofoam, or PA, acrylic, or nylon. Or maybe the one that hard, the for example, let me find something. So, or maybe this one, the LED or the screen. It can be from epoxy or phenolic, from polymer, which is hard. And then there's elastomer. Elastomer is rubber, rubber, natural rubber, silicones, or synthetic rubbers. And then glasses. So glasses, it can be from your glassware, it can be from your the bottle, it can be from your laboratory ware, glass kimia, and it's called glass kimia. It's called borosilicate glass, or your ordinary glass is called soda glass. It's called soda glass because it's not contain soda, it's contain water, but it is actually made from sodium. Ada sodiumnya, ada natrium. Okay, and then ceramics, and the ceramics is actually alumina, silicon carbide, silicon nitride, and zirconia. And the combination of that, we call it hybrid or composite. It can be composite, which is we mix them in the microstructure level, or just to berlapis-lapis, sandwich panel. Okay, okay, now anyone want to have a questions? Not yet? Right. Okay. So now for to conclude, I'll just explain a little bit about the general characteristic of metals. The metal is generally stiff. Stiff means kekar in Indonesia ya. Stiff means you can't move it ya. It's difficult to bend, susah untuk bengkok. Yeah, the stiffness is actually connected to the high elastic modulus of elasticity, and it is when it is pure, it is very soft and easily deformed, gampang bengkok. If your mom or have a bracelet or a necklace from gold, and the gold is, if you use pure gold, it is actually very soft and then you can bend it, bisa dibengkokkan, ya. And then so it can be strengthened, bisa dikuatkan with alloying, with adding some other metals, or using a mechanical treatment. We draw it like this, ditarik, or using a heat treatment. Okay, so this is, for example, processing, we call it rolling. So they roll it, this become a sheet, and the sheet is going to be based for making pipes, making the reactor, yeah, the wall of the reactor and so on. And this picture tells you about the casting, mencetak, yeah. So this is the molten metals and it's casted. This one is to machine, yeah, like a blocks, and then you make a machine it. Okay, and this one is to make a coil, yeah, to make a coil, kumparan, from the that one there. Ceramics, the characteristics is of course a very stiff, sangat kekar, and it is brittle, rapuh, it's not ductile, so it won't bend, but it's just gonna break. Okay, and the compression strength is usually much higher, the tensile strength. And then also it is hard and abrasion resistance, corrosion resistance, and retain strength at high temperature, and it can be glass or it can be non-crystalline ceramic. So from your labware, from this one in the pipe there, from ceramics, or using the material inside the furnace, or using this one, concrete. Okay, and the last one is the polymers. The polymers, of course, has the very lowest elastic modulus, and it can increase the strength. It exhibits like deformation, with, for example, for the piping, for the valve, for the casting, mencetakannya, and it's easy to shape, and corrosion resistance and low coefficient of friction. Okay, so in the end, okay, so the material selection, the significance of material selection is the cost. Okay, so for example, this is the material frequently represents a significant cost of components in a process equipment. For example, this is a type for CNG tank. So this is the car which is fueled by the CNG, compressed natural gas. So this is the total vessel cost, and then how many vessels per year that they can build. If you look at here, if we only produce 200 vessels per year, there's quite high cost from the helium fill and leak test begin increasing, the liner formation, material production becoming increasing, the fiberglass also increasing, and so on. But if you increase the vessel per year, the total vessel cost becoming lower, except these greens, yeah. And these greens is actually explaining about the composite material. So the cost of composite material, it doesn't change for the total vessel cost if the vessel is produced 200 or 10,000. Yeah, so the material cost constitutes a very substantial cost when we want to build the materials. Maybe we can reduce the other costs, we can use the office cost, the overhead cost, but not the material cost. So once we know the material selection, so that is going to be the base. Okay, and then this one, yeah. So of course we don't want this to happen, but it did happen. So this is the Humber Estuary, UK refinery explosion in April 2001. It is caused by catastrophic failure of a gas pipe that has undergone thinning due to erosion and corrosion. So here there is this a pipe, and the pipe become thinning, manipis, yeah, because of there is erosion inside and also the corrosion. Okay, and then this gas pipe make the explosion of the refinery, and there's no life or loss, but the damage will total almost $82 million. And then the company also required to pay fines and repair costs for the total community over 1 million pounds sterling. Okay. And then this one as well, the example of material selection for significance, the product which comply safety, health, and environment. Okay. For example, this is the clockwise from the upper S. This is the COP, crude oil palm tanker under construction. Okay, and this one is the CNG tanker truck, the compressed gas, and this one is the milk tank, tangki untuk membawa susu. Yeah. Can you identify the difference in the term of material employed related to the products contained which this tank? Okay, of course, if you have a different commodity inside the tank, you have milk, yeah, because it is food industry, so we have to make sure everything is not contaminated, so they need to use stainless steel, yeah, full. Okay, this one, COP, crude oil palm. Yeah, we can maybe using a carbon steel, that's fine, because it is oil and then it's not oxidized. Okay, and then this one is the compressed natural gas. You can see here that there is a difference here. Of course, you have to understand the thickness and also the materials as well, yeah, because it is a pressurized tank. Okay, so so with different commodity, with different application, we will have a different material selection. Okay, and this one also the famous material failure, which is the Titanic, yeah, which is not so unthinkable. So this one, yeah, so this is called rivet. In Indonesia we call it paku keling. Okay. So this rivet were used to seal the hull, the plates together. There is one plate here and then the other plate there, and then it is tightened up with those rivet and then hammered it at those ends. And then there is a pressure with the iceberg here, will cause the rivet will pop along. So because it is tightened, and then the rivet is pop along, and then because it's pop along, then the total area, then this one is just open, and when you have to open, you get the water inside, and then almost 34,000 tons of water seep. Okay, and so this rivet is actually based on the brittle fracture of high impact loading, terlalu kaku, yeah, that one. So with the ship traveling nearly 25 miles per hour, the contact with iceberg would be a series of impact, so cause rivet to fail or even shear by elongation. Okay, normally the rivet would have deformed back, nggak akan pecah, ya, usually, but because of the temperature is freezing, because it is a very low temperature freezing, so the rivet become brittle. Okay, if you have maybe a plastic bottle and then you put it into the to the fridge, yeah, to the freezer for a few times, when you open it and then you just smash it, it's just gonna smash into pieces, right? Because a material, when it is in lower temperature, it's gonna be brittle, jadi kaku. Okay, so because of that. Lastly, this is the famous materials comments, or maybe I'll skip this one, or this one. This is the Space Shuttle Challenger. Yeah, all the crew aboard killed in 1986, and it's actually based on this O-ring. So the O-ring become too cold. The O-ring is made from rubber. It become too cold and then become again brittle, pecah ya, brittle and failed, and then the hot gas leakage ignite the liquid nitrogen tank, and then ignite the liquid hydrogen tank, and then there would be fire, and then all the crew aboard were killed. Okay, so so sometimes the failure, it came not from the very big or the majority of the material, but sometimes a very small part of material. For example, this one's O-ring, yeah, this one here, but the liquid nitrogen around this one. Okay, so that's why it's very important for us to still understand even onto the details. All right, this is the end of the slideshow. Before we stop, any final questions? Not really. All right, next tomorrow we're gonna see you again, and then I'm gonna prepare the presentation beforehand, and I think we're gonna continue tomorrow. Okay, everyone, I think that's all for today from me, and then keep safe, don't forget for the health protocols, ya, jangan lupa protokol kesehatan, and then I'm gonna see you again tomorrow. Thank you.